We've got an awesome webinar for you all today, kind of a different format than we're used to, more of a panel presentation today. Ask Keith Parsons, and I know a lot of you had submitted some questions before today's webinar. Thank you for doing that. It certainly helps us with the presentation, but for those of you who didn't, you obviously have the ability to ask questions as we go today. So tons of content ahead of you all. I'm going to hand the controls over to Jim so he can present today's speaker, who probably needs no introduction. And Keith, I'm going to hand you the controls while we do that.
Yep. And while Keith is getting prepared, I'll just say a few words. Keith Parsons, if you don't know him, he is a world-renowned wireless network engineer, trainer, and podcaster. His website is WLANprofessionals.com. He's at Keith R. Parsons on Twitter. He is CWNE number 3, and he is the host and organizer of the WLPC conference. Really looking forward to getting back to Phoenix in 2022. So welcome, Keith.
Well, thank you. I too am looking forward to having another WLPC. It's been a long time since we were together. Luckily, the last WLPC was right on the cusp of when COVID hit, and then we've had, a crazy last year, 18 months. But WLPC will be returning February in 2022, so I hope to see you and lots of other people there so we can get together in person and do these things. So the topic today is just Q&A. So I just put this little teeny slide saying, that's what we're talking about. Let's go ahead and we'll move this out of the way and go on to the first question.
Sounds good, Keith. So question from Vaz. He says, do you believe Wi-Fi 6/6E WLAN connections will eventually replace the majority of LAN connections for end users?
That's a tough one, because right now I think Wi-Fi 4, 5, 6, whatever Wi-Fi count you want to go with, Wi-Fi has already replaced almost all wired LAN connections. I was reading a report, actually this is probably 5 years ago, of the state of California in the United States. They have a series of schools, UCLA, University of California, Los Angeles, UCSC in San Diego, they're all over the state. And they were running and found that they were running a bunch of, and this is the first time I heard this term, dark copper, that they had run cables to all of the dorm rooms, all the lab rooms, everywhere there was, and found that people just weren't using the copper. That the number one way people accessed the internet and the local network for the college was via Wi-Fi. So one of the things they did was take the budget they had every 7-8 years, whatever, to upgrade the switches and the routers and all the wired infrastructure, and they redistributed that money to put it into making better Wi-Fi. So I think we've already crossed over that point. Most people access the internet through Wi-Fi. I can ask my grandkids, and that's the first thing they do when they walk in a restaurant. They ask the waitress, what's the Wi-Fi password? It's just the way to get on the internet.
Yep, I agree. That's a trend that's been going on for several years, and I think a lot of shops, particularly in education and some other sectors too, when they go to do switching refreshes, they discover they need half or less than half of the switch ports they used to need. Everything's going Wi-Fi, and in some places it's it's called an all wireless office. We're only going to do Wi-Fi, and that's the entire access layer for clients. So
totally agree with that. I think we're already at, most offices are already all wireless. They have things like printers on a port. Obviously all
Don, I think we may have lost Keith there. Oh, here he comes.
It's just at the access layer. The other thing you need to think about if you're designing your own Wi-Fi is in the past.
Hey Keith, we're losing your audio. Maybe we'll have to stop sharing video in order to get the audio to come through.
Today, and actually probably for the last decade, the aggregator is the access point. And so when you took an aggregator and you put it in front of another port that was supposed to be an aggregator, the old access layer switches, we had some congestion going on at the switch. So we just need to think about that moving forward, that since we have APs on the edge now, they're aggregating data from multiple users, 10, 20, 30 users, into a single uplink port. That switch port now no longer has that role of aggregating. It's just pushing the data. So we need to design our switch fabric to look at those and think, they have a different role now.
Thanks, Keith. Hey, your audio broke up a little bit, so Don and I went ahead and turned off our webcams just to save a little bit on bandwidth. So you're welcome to do that too if you want. Next question here.
Thank you.
Is if Wi-Fi 6E is coming, what is the benefit of upgrading to Wi-Fi 6 now? Why not wait until new Wi-Fi 6 APs are available and take advantage of the new spectrum?
Hey, Don, you want to switch over and I'll share my screen again?
Absolutely. There you go. You should have the control now.
There we go. So here's just Wi-Fi 6. Some of the things that you get with Wi-Fi 6, and you've seen these a lot, and I've seen some of the questions that came in, and it's like Wi-Fi 6 versus Wi-Fi 6E. Well, all of the features of Wi-Fi 6, 802.11ax, are also available in 802.11, Wi-Fi 6E when we add the 6 gigahertz to this. So these features are still there. The question is, one, are we getting those today? Two, are we going to get anything better if we wait until we get 6 gigahertz? And those are really good questions, and it really has to do more with layer 8 issues, not necessarily the technology of today, but how does this fit within your budget cycle? When will you have the money or the budget and the time to do the upgrade? Because you have a couple of things to talk about. First, as we move to Wi-Fi 6, these features that are here are only available if you have clients that are also Wi-Fi 6 capable. So just a simple one, we can look at 1024 QAM. Obviously, if your client isn't 1024 QAM capable, there's no way that the transmissions to and from the AP can use that feature unless both sides have it. Same with BSS coloring, same with OFDMA. All of these extra features that are available to us in AX come when we get enough clients on board. So these have been around literally for years, and we have just barely become certified from the IEEE that this AX is actually now certified and ratified. So one, you have to have enough clients. Now we're getting there. My phone that I carry in my pocket, it has Wi-Fi 6 capability. It knows how to do these things. But I'm not really sure how many of these features will be live and when in your specific network. So whether you're a Cisco, a Ruckus, an Extreme, a Mist Shop, Aruba, they all have these features built in because they're part of the protocol. But how well they're baked in and whether or not they're tuned is still a thing to look at. So moving from, let's say you're an 802.11 AC shop today. If your AC is doing what it needs to do today, then we're good. Do you really need to upgrade? So think about that. Now, on the other hand, if you're 802.11n and they're end of life and you need to upgrade now, well, Wi-Fi 6E is just barely on the cutting edge, and we're not going to have them probably till the end of this year, early into next year. So let's think about when you're going to be making those changes. The question was fairly simple. If I can put in a Wi-Fi 6 today, should I do that or wait for Wi-Fi 6E? The answer is a little more complex. And like the teaser that Jim Vajda put out for this session, it all depends. And it's not about a technical question. It depends more on where you are in budget cycle. Let's go and look at some answers, though, on some of the technology differences. With my friend Fernay and I, we went and did some work. And we went and did a bunch of surveys and then to see what's the difference between a bunch of different APs. And here's a bunch of different APs we did comparing the access points over distance. So the first distance that shows the highest level, the darker blue, this is at 10 meters. And then we went out to 20, 25, 50, and 100 meters out. And you can see that when you're close to an AP, you get an advantage. There's an extra little boost there on that when you're close. Doesn't matter which AP it is, they all show when you're within 10 meters, you have an extra advantage. But then they slow down as they go out. You can also see in this, though, that different APs had a slightly different value. As you went out further, the cambium, the one on the far right, and I'm not saying cambium is better than the mist next to it, but what we're trying to see is what are the differences between not just APs, but in this sense, we picked different APs for their different capabilities. The first one was an non-AX AP. The second two were AX capable. And the fourth one on the right side, not only was AX, but it was AX with 8 spatial streams. So in this view, we can see we got a slightly better result having more spatial streams. But the biggest result is design around close. That's just one view. Another set of the data we looked at, and this is just, I'm zooming in on just one piece of information alone, comparing a MIST 43 AP with 4 spatial streams to a cambium that had 8 spatial streams. And you can see it doesn't matter what the distance was, the 8 spatial streams gave us better results. Now this was across a wide variety of clients. So it didn't matter what the client was. Some clients had 1, 2, or 3 spatial stream capability, but they were all better when you had more spatial streams. Not saying anything about cambium or MIST comparing, just saying the spatial stream shows off. Another view we saw in doing the same kind of data set, and this is from the client standpoint. Now this client on the left, the one that's got the highest numbers in the dark blue, is a ThinkPad. It's actually a really old ThinkPad, but we added an AX client to it. The MacBook Pro client, which is normally the best we see when we're testing, is the orange. And then the gray was an iPad with 2 spatial streams, and the last one was an iPhone. And these are over distance. You can see across the board that the AX client outperformed the non-AX clients. So to help answer your question, the more AX clients you have, the better your results are going to be. The non-AX clients still work. Obviously, we have data that show that's not a problem. But if you need that boost today and you have AX clients today, move to AX. My personal opinion is it's more of a budget issue than it is anything to do with the technology. I don't have a 6 gigahertz client yet, so it's kind of hard to say, oh, wait for these, because they're not even around at this point. Did that help? You have any feedback on that, Jim?
That was a great answer, very thorough. I mean, to expand on the budget issue, Wi-Fi 6E, probably are going to be 3 radio APs that have that are going to be pretty hungry for power over Ethernet, and you may think about upgrading your switching to multi-gig switching. So it could be a pretty expensive jump. So something to consider.
Yeah, I agree. Not just it. You have to look at the entire infrastructure to support it. Hold on, I think I actually might have some supporting data to show that as well. Oh, anyway, go on to the next question. If I pull up that data, sure, we'll move with it.
Yeah, so I'm going to summarize this next question, but here's a person that has an existing 802.11ac Wave 1 WLAN and they want to add APs to get additional coverage. So they're asking two questions. So should they expand with 802.11ac Wave 2 access points or Wi-Fi 6 access points? And
it's kind
additionally, yeah, the second question is, what about mixing access points with 2 spatial streams and 4 spatial streams?
Oh, there's some good questions. First up, I just have to refer back to that first answer that I just gave. Moving to A or AX or Wi-Fi 6E, they all have to do with whether or not you want to upgrade today. I have customers who are still running 802.11g, and it's meeting their requirements. So as long as you're meeting your requirements, I don't see any reason to have to upgrade. Most of us, though, have increased our requirements over the last couple of years, over the last decade, or 15 years since G came out, and to have better infrastructure in order to support the higher requirements. So my first answer to you on that question is, what are your requirements? Are you meeting your requirements today? If you're not meeting your requirements, then you have a very good reason to move forward. I recommend moving to whatever the latest technology is that's cutting edge. I don't know if I'm going to move to bleeding edge right now. That's a big jump, and then you might have some extra issues on top of that. So if you can afford to wait for 6E, wait for 6E. There's a lot of extra features that are going to come there. If you need to upgrade now, upgrade now. So not a definitive answer, because it does depend. Next question up.
Yeah, Keith, what about mixing APs with different spatial streams, say 2x2 and 4x4 in the same WLAN?
Oh, love this question. I love answering it, actually, because what I see a lot in the industry is, well, let me back up. First, let's talk about how vendors design their access points. They usually come out of the gate and they design the top of the line 4x4 AP, and they put all of their engineering effort into designing the antennas and the power systems and the capacitors and the batteries and the heat sinks and all of the parts that go into something called COGS, the cost of goods sold. It's all the parts that go into an access point. And though they're cost sensitive at this stage, they're not terribly cost sensitive. What they're after is, we want to design and engineer the best. And the engineers actually have the best time designing this one, because they have almost, carte blanche to start with and say, how can we make this the best AP possible? And then they have their top of the line AP, except for salespeople. And I've seen this for nearly 20 years. Salespeople like selling the cheaper product, not because it's actually a better product. It's not, but because it makes sense to sell more cheaper APs to the salesperson. In reality, here's the difference. They sit in a room and they say, we have this wonderful thing we just engineered that does the best that our company can make. What can we do to lower the cost? Because we need a lower cost product. And so they sit around, the same engineers that just had fun making the best thing they could make, the best engineering, and they say, well, how much is it going to cost to change this resistor pack to lower quality? And is it going to affect the output? And then this capacitor and this chip and this RAM and the CPU we use and the heatsink we use, and they take parts out. They're making their own product worse. Literally making their product worse in order to meet this lower cost of goods number. So let's say in the industry we have a 6-to-1 ratio from cost of goods sold to the retail MSRP. If you have a $1,200 AP, the cost of goods sold would be about $200. Now, if you want to lower that to $600, your cost of goods sold has to go from 200 to 100. That means you lose 50% of all of the parts. You're going to lose quality, you're going to lose capability, you're going to lose capacity, and you'll have a product that even though it might use the same Wi-Fi chip, the rest of the supporting pieces are less. And then if they need a lower quality one, they'll do that cycle again and again, every time getting a cheaper product, but having less and less capability, less and less capacity. So we know that if you have a 4x4 AP, you'll have better results than if you have a 2x2 AP across the board. MRC is one of the reasons for that. But the big reason is you're putting in better quality parts so it can listen better and it can transmit cleaner, the two things that allow it to talk faster. So when we go to a 2x2, we lose those capabilities, but we save money. Now the question is, do you want to mix and match? And here's where I said I like answering this question, because a lot of salespeople go out and say, well, we're going to put in the cheap APs. Let's pick an example of a hotel. We're going to put a cheap 2x2 APs in all the rooms, or every other room, or every fourth room, whatever they design. And then we'll save the really high-end, nice APs for where we have higher capacity. And my question then is, why, if you know this AP is a better AP, why don't you put the good APs everywhere? Now, obviously the answer is cost. But what happens when you run actual test results? The 4x4 APs have obviously higher capacity, but they allow clients to get on and off the network quicker because they keep a higher data rate, meaning they can have more devices work with them. Why would you not want that everywhere in your building? Now, here's another couple of things to think about. If you have a higher end AP, has higher capacity, more users can use it, talks faster, all those good things, it only uses up one switch port. If we go to lower end APs, we'll need more of them. We'll need more switch ports. We'll need more PoE. We'll need more licensing. We'll need all these other costs that go in. So when you look at it overall, and for my customers, we've went through these numbers many, many times, probably 100 times the last 10 years, going over and showing it's actually a net cheaper. Your total cost of ownership will be lower if you put in 4x4 APs across the board. You get better results. The difference is the AP cost is actually higher, but the TOC is lower. So to the original question, I don't like mixing and matching APs in my designs, especially new and old, AC and AX, 2-string, 4-string, anything that gives a reason for the vendor to say, our controller had this issue, our cloud controller, you have a mix of these APs and these are end of life and these aren't, so you have to maintain older code. There's a lot of technical reasons why mixing and matching makes things difficult. If you have to mix and match, I would do it by building. And we've done this with college campuses, schools, K-12, hospitals, hotels. Do it by building. It takes a little more labor to move things around, but make one building the 4-stream building, another building the 2-stream building, or one building is the AC and one building is the AX, so that at least you can keep that group with the same software, the same firmware, all the same code base. Did that answer your question?
Think so. Thanks, Keith. Good question here again on 6 gigahertz. And Michael asks, if I'm planning to reuse the same AP cable drops for a Wi-Fi 6E design, what dB offset should I use now for planning those that 6 gigahertz coverage? I think he's trying to say, is there a, if I have 5 gigahertz coverage, is there a rule of thumb that I can use to infer what 6 gigahertz would look like in the same design?
Yes and no. The actual difference in dB, we'll add, I'll give to Jim and he'll put it up here, a 6 gigahertz chart. I'm not going to show on the screen now because it's just big thing, but you can actually calculate the difference in dB between a channel 36 and 6 gigahertz channel. It's a very slight offset, but that's not your real question. Your real question is, can you just use your old cable drops and do a swap? Now, one of the rules we came up with, maybe 10 years ago, and it hasn't changed in the entire time here, is when you're swapping out access points, do a redesign. Now, there's two strong reasons for this. The first strong reason is, I'm betting if you are moving from one generation, GNAC, to the next generation, your requirements have changed. And because your requirements have changed, you need to redesign to meet those requirements. Just using old cable drops and swapping out EPs isn't going to make sure you get the same results. You need to meet your new requirements. That's the entire reason we want to redesign. But on the other hand, you have this cable plant you've already installed, and you don't want to pull all new cables. So one really easy trick, it's not a big deal at all, it takes just a slight amount of effort, is you find out what's the normal service loop on your current installs. Hopefully they've installed, I don't know, 5 meter, 10 meter service loops at every location. Even if they haven't, they might put a biscuit jack there so you could change the length of that last little patch cable and find out what that distance is. Then I take the current layout on the floor plan and bring it into either a CAD drawing or Photoshop or whatever tool you're going to use to draw on, and I draw little red circles. The diameter of the circle is that service loop, and I put that everywhere where there's a current cable drop. Then I pull all the APs out, so I just see these little circles. Then I start the new redesign. During the process of redesigning to meet the new set of requirements, as I'm thinking about where to place the new APs, because they have new features, they have new distance, they have new whatever the difference is, I use those little red circles as my targets. It doesn't mean I must use those. If there is a better placement to meet the current requirements, we'll pull a new cable. But with those little targets on board, I can probably end up, instead of reusing 100% of them, I can get away with 80 or 90% and still meet all the new requirements by just thinking first, if I put them there first, then where do I have to go? So again, meet all your requirements. That's the number one thing you're designing for. You can use those old cable drops to help you lower your cost, and you don't have to pull all new cables. So the best of both worlds is do a redesign, don't do a in-place swap, but you have that little distance of that service loop to help you perhaps tweak it or tune it a different way. Another thing I like to tell my cable installers, I go around and I like to hire the cable guys to install my access points. They're already there with ladders, they're up in the ceiling, it saves a whole bunch of trouble to not have to have another group come in behind them to do the install. So I have them install. If my design is so brittle that if a cable installer moves it 5-10 meters around within the same room and it breaks my design, I should have designed a little more robust. So I like to design and then change it, moving them 4-5 meters in any direction. So when I go to the cable pullers and say, hey, you're up in the ceiling, you're pulling this cable, I know the best spot was here, but I'm just going to give you some rules. Try to stay within 2 meters, away from within 2 meters of a wall. Don't put it right next to a projector on the screen. Give them some rules and let them bring the cable drop where it's easier for them to do it, saving me for that 1 or 2% of the time where I must have it within 1 meter resolution in order for the Wi-Fi to work. And then I allow the cable guys to do those changes. So yes, your cable drop locations are important, but they shouldn't define where your next design is. You still need to go through the design process.
Good points. Thank you, Keith. So maybe a little less technical question, but question here. I am starting my own IT consulting company providing services in wireless and security in my city. Any tips or hints are greatly appreciated.
Thanks for the question. I kind of started where you did. I was I remember, probably 20 years ago, I was trying to figure out why, not why, I knew why. I was working with a lady by the name of Laura Chappell, and she's fantastic at packet analysis and could charge really decent consulting fees. And I'm at dinner with her one night, and we're talking about this very issue. Should I go into security or should I go into wireless? And she said, well, which one do you like more? So I like them both. Security is cool, it's fun, it's exciting. And wireless is over here, it's new. And she just flipped a coin and it landed on wireless. So I've been doing wireless for the last 20 plus years. Quite fortuitous. I don't know if I would have enjoyed security as much as wireless, but I'm 100% sure that I would have been terrible if I tried to do two things at once. So my first recommendation is pick one, either security or wireless. They're each huge domains all by themselves, and to stay on top of it takes a lot of study and effort. And I've done probably 2, maybe 3 certifications a year for the last 25 years, and I'm just barely staying on top of the changes in Wi-Fi alone. I couldn't be doing that with security too. So I think you need to focus on what you're going to do. I know as you're starting out a company that it's relying on you. You basically take any gig you can get just to put money in the bank. I get that. And for a while, maybe you have to do that. But if you can focus and get really good at one thing, you'll be able to charge more. Now, here's a trick I learned at least 20 years ago. When you're on your own, one of the things you need to have is your business as an independent needs to not punish your family. Now, what I mean by that is you're choosing to work for yourself, which is a good thing. I strongly support it. But you shouldn't be punishing your family by having them live through the variability that happens in your income. So I call it the bucket method. Take the money that comes into the business and it goes into a bucket. That bucket drips into the family bucket, and that drip needs to be constant. So whatever you earn from your business to your personal accounts needs to come in a constant rate. Now, the problem with this is sometimes the income going into the business is variable. Thus, treat that bucket like a reservoir. You might have a really big gig and you make lots and lots of money and it's like, whoa, we're so happy. Don't share that with your family. It's hard because it was a success and you liked it. The problem is if you flow that extra money through into your family account, which happens when you're excited and, oh, we got this, we can go buy a new car, we can do whatever. The next month might not be a good month. And then what will flow through is nothing. And then your family life is up, down, up, down, up, down. And it's hard to stay. What we like is the stable income that comes from working for someone else, but we like working for ourselves. The solution is multiple accounts. Keep the business separate from the personal. And I recommend having the business drop into the personal at a constant rate. Figuring out what that rate is you're gonna have to work through those numbers yourself. But don't allow all the good or the bad from the business to affect your family. I hope that helps.
Thanks, Keith. Hopefully you didn't learn that the hard way.
I did.
Yeah, I think a lot of small business and sole proprietors do as well. All right, so another Wi-Fi question. So in some webinars, Matt asks, I have heard it suggested that beacon rates for 2.4 gigahertz should be increased to help reduce airtime consumption. Can this be done successfully? Sorry, go ahead, Keith.
I think the question meant decrease. Because if you increase the beacons, you get more per second, you'll actually lower your airtime available for data. So that's definitely out. We don't want more beacons in the air. It is a possibility to lower the beacon rate and free up more airtime for data because I'm not sending a beacon, I'm sending data. That's a true statement. I haven't found it to be actually that successful in the real world. Many clients, though they're 802.11 capable, they're Wi-Fi certified by the Wi-Fi Alliance, don't have the ability to adapt cleanly as those beacon rates change. A better, far, far better way to do it lower the number of SSIDs you have. That's an easy answer. If I have 2 SSIDs, that's 2 sets of beacons going out, each one 10 times a second. If I only go to 1 SSID, I just cut my beacon rates in half, and I didn't have to change any client effect. So my recommendation is to not touch the beacon interval. It's normally, it's in a weird answer, it's in kilo microseconds, but it's basically a little over 1/10 of a second will be sending out a beacon. So we could change the beacon rate to instead of 10 per second, 5 per second. That's lowering the beacon rate, freeing up more airtime, but then some clients could have difficulties. An easier way to accomplish the same goal is just get rid of unused SSIDs. Most recommendations for SSIDs are you need 1 for each method of authentication. So if you have open authentication, you just need 1 of those. If you have PSK, you need 1 of those. If you have .1x, you might need 1 of those. If you need more VLANs, you can have a dynamic VLAN assignment with a .1x account. So the .1x account says, here's my username, password. Along with that, in the database, it says, oh, you're in marketing. So if you log in, you will be dropped into the marketing VLAN, and I only used up 1 SSID. But realize, SSIDs do not equal VLANs. 2 separate issues. SSIDs, by putting multiple SSIDs, does not change the sharing of the data. So if I have a finance VLAN and a marketing VLAN, and I have them both tied to SSIDs, those linkages exist, but the SSIDs are in a shared medium, so it doesn't split up your data at all.
Yeah, and one thing I'd add there is if you make the beacon interval longer, that's going to have an effect on roaming as well, because it will increase the chance that a client will miss a beacon while it's scanning and not become aware of a nearby AP as easily.
Or just take longer to do the roam, which means it's off channel. Scanning takes longer, it's roaming takes longer. There's just a lot of bad things. Just don't go there.
So Keith, here's a question about high capacity environments. And looking at our time here, this should probably be our last question, but it's a tough one. So first, what's the best strategy for high capacity Wi-Fi environments? And to be a little bit more specific, Hans asks, what about with very high throughput requirements, say over 25 megabits per second in a classroom with 25 devices? I assume that's 25 megabits per second per device.
Yeah, one, he used the word classroom, so I'm thinking K-12 kind of environment. And sometimes we come across customers who ask these kind of questions because they have a legitimate concern, and they're looking at this solution and they have a need, a requirement, and how do we fix it? But before I answer the question exactly, I'm going to back up and say, in a K-12 environment, we have students, and all the students should during the day go to the bathroom and eat, and both of those 2 things. Now, when you're designing a school's cafeteria, and let's say there's 500 students in the school, you could design the cafeteria with 500 seats, that all students come in at the same time, they all eat at the same time. So you'd have to have the capacity of 500 chairs, 500 tables, the kitchen size to take care of 500 students all at the same time, the kitchen staff to be able to feed them all at the same time. And years ago, decades, probably 100 years ago, the designers of schools figured out, yeah, that's really inefficient, because for just a slight period of time, all the students were in one place, and then they go back to their individual classrooms. Why don't we just save money and be more efficient, and we set up the cafeteria to handle perhaps 150 students or 160 students, and then we send them through on 3 different shifts. Now we have to have 1/3 of the size of cafeteria, the 1/3 of the staff, the 1/3 of the kitchen, the 1/3 of everything, and we have them do that. Same is true with bathrooms. We don't have 500 toilets in a school. because we know that all the kids don't go to the bathroom at the same time. There is a ratio. And for building designers and architects, they actually have those ratios written down depending on the type of environment it is. In a stadium or in a school or in a hospital, they have bathrooms at a certain ratio compared to the attendees. Now, back to your question. There could be a need for a student's laptop to download 25 megabits per second. I get it. There are apps that require that. Are there apps that require all 30 students in the classroom to all download 25 megabits per second simultaneously? I doubt it. Like going to the bathroom, it happens not at exactly the same time. So what we want to do is design our high capacity, whether it be in a LPV or in an auditorium or in a classroom, to meet the requirements that they have. Not the ultimate, not the everyone doing the same thing at the same time, because it's very rare in reality for the same thing to happen at the same time. I'll go back 20 years. This is with Novell, like long time ago. And they were trying to design read access on their servers. When someone wanted to open a Word document or a WordPerfect document, it would go out, find the document, and send it over the wire back to the customer. Now, the difference between WordPerfect and Word was one needed, and I forgot which one was which now, but one needed to start at the beginning, read the entire file to the end, and then transfer the entire file at once. And the other could read the first sectors on the disk and send it up, and the file would open on their screen, and they would think that they're already started, but the tail was coming later, and it took over time. One looked like it was slow, one looked like it was fast. In the end, after 3 or 4 seconds, they all existed exactly the same place, but they had a different flow. And so if you were testing a network drive and you open an Excel file versus a Word file, and they have a different way of going out and getting the data off the disk, one would look fast, one would look slow, but given a wider window of time, a bigger time frame, they both downloaded the same size file in the same size amount of time based on the metrics of the system. So when your customer asks for 25 megabits for 25 users simultaneously, I would push back a little bit, because that's not terribly realistic that all of them are going to at the same time. The reason I am pushing back is there is no Wi-Fi networking capability today that would allow for the thing you just asked for. Doesn't matter whose APs, whose clients, AX, AC, Wi-Fi 6E, none of them can deliver the thing that you ask for. Sorry. In reality, that's a very, very big ask. So what instead we do is we push back a little bit and find out what is your real requirement. Now, one, all 25 users are going to be associated, so we need to have a big enough association table to handle them all. Of those 25 users, are they all hitting it simultaneously, and for how long? And how long does it take? So get a little deeper. The reason I give you the example of the Excel versus WordPerfect data file is the thing that you ask for that may pull down 25 megabits might be a streaming app, and it pulses. It pulls it down and then waits, and it pulls it down and it waits. That's the way they work. So find out a little more details about that and look into what is the reality of how much data you can actually push over Wi-Fi in a period of time. Jim, I'm sure you've seen this as well in a lot of your customers. What is I mean, even when you push Wi-Fi really, really hard, it doesn't exceed a gig, even today.
No, and as you start to add more users, the aggregate throughput starts to go down because of airtime loss to contention. So, just back the napkin math here, 25 megabits per second to 25 devices simultaneously, that's over 600 megabits per second. You need 160 megahertz wide
net
channel to be able to really do that.
Data.
Yeah.
That's not the speed of the air of the RF. That's what they want to expect net. But it also is constant, and I've never seen constant pulls. It's just a rare thing.
Yeah, even with what's called streaming video, and I suspect, if I were to guess, I'd say they're probably thinking about 4K streaming video. It doesn't actually stream like a like what we're doing now, like a voice call streams. Streaming video from the internet is usually coming in big chunks, and the chunks are cached, and your video player plays through that chunk, and when it's time to get a new chunk, it downloads it.
Yeah.
So there's a lot of airtime utilization, and there's very little if it's building up that cache quickly enough. But a couple things there.
Now you could look at this from a salesman standpoint. If I was a salesman, I'd go, oh, well, that means you need 4 APs per classroom to meet that requirement. And since you said it was a requirement, we have a solution, and then we would use 80 megahertz channels in each classroom with 4 APs, and you could meet that requirement. It would just mess up the room next to you and the other room across the hall. But you don't care about that because you just sold a whole bunch of APs and you walk away, and your answer was, but you had the requirement and we met your requirement. And then you'd have other issues later on, but that's probably someone else has to deal with it.
Yeah, you could make it work in a single classroom, but the real packets coming across the wireless probably are not, to Keith's point, 25 megabits per second, constant throughput to every client. And if it's a video application, it's probably more than capable of, going down to 1080p or 720p or 480p and still working just fine. And if you must have that high-res 4K video that every student sees at the same time, we'll put it up on the main screen in the front of the classroom and let everybody look at it there. So a lot to dig into
I had a
to really
ask
understand
for,
what the requirements are.
I had a customer ask for 5 devices per student, 30 students per classroom, because that's what they were projecting in the future, and they wanted to future-proof their design. So I get it. I understand if that's what you think is going to happen. But even if there, and by the way, one of the 5th devices they talked about was, they literally said this. They were going to have Wi-Fi powered underwear, as in underwear that had a Wi-Fi chip in it that could tell people if my kid got kidnapped or something. I don't know. I mean, they were going crazy.
Weird.
Watch, phone, pad, laptop, and then the 5th one that just made this underwear thing up. But even if you have all those, and all 5 of them were available per student in the room, they would all be associated. But which of those is going to be actively transmitting data at a time? We only have one brain. And though I have multiple computers in front of me, I might get one going, but I can only focus on one thing at a time. It's just the way humans work.
Yep. Yeah, the only thing that can happen sometimes is if you've got, if you have a lot of students with iPhones and laptops, and the new iOS update comes out, and they all show up in the morning, and oh, the iPhone suddenly has Wi-Fi connectivity. Let's start downloading gigs and gigs and gigs of that OS update while we're just, sitting in the pocket. Sometimes that happens.
I've dealt with that very issue on a couple of large public venues, and we got around that by allowing data to go out to that iOS update, but then putting it through a filter that gave it a really small pipe. So instead of hitting our network and having lots of load, we found if we turned it off, people would complain, something's wrong with my phone, it went to download and it did it. So instead, we allowed them to go through, gave them a little teeny pipe, and so it didn't really affect the airtime or our big pipe out to the internet, and allowed them to just take it slowly. So knowing that those things exist means we can solve for them.
Exactly. Yep. Yeah, another example of why it's so important to know what clients you have on your network, even the guest clients. So, well, thanks, Keith. I think, Don, with that, we're a little bit over time. We should probably wrap it up.